Okay, so you've got access to this Cami, and I'm going to do a video demonstration of how to do one of these questions with your GDC so that you can do this in asynchronous learning, of course, because some of you are in school this morning. And so these lessons, when some students are in school, are set as tasks on your Google Classroom for you to do in a time which suits you best. So asynchronous, not synchronized. Enjoy this, but you watch this video and then all the other questions on the Cami are up the top here, but this demonstration one I'll do down here. Celia deposits 500,000 euros in an annuity fund which earns 4.5% per annum interest compounded monthly. Celia wants the money to last for 20 years. How much can she afford to withdraw? So we looked at this last lesson. There's examples above there, but I'll just do a video for those of you who may need this extra little bit of help. So here we go. I'll use my GDC straight away onto your calculator. Whoops, a daisy. Let's try that again. Onto your calculator. And we've got some information here, but we are always going to be using the finance app on our GDC. So we go to apps, and then finance app number 1, TVM solver number 1. So let's look at the information we've got. Celia deposits 500,000 in an annuity fund. Let's mark up the important things here. It's 500,000 euros that she's putting into this annuity fund. It earns 4.5% per annum interest. It's going to be for 20 years. It's compounded monthly. And how much can she withdraw each month? How much can she withdraw each month is the question. So 1, 2, 3, 4, 5 pieces of information. We're going to input those 5 pieces of information into the calculator. First one, let's input the information of the deposit, 500,000. So 500,000 euros deposit. She's giving away, so present value, she is giving away minus 500,000 euros. She's giving that into the investment fund, the annuity fund. So giving away 500,000. That's the first one. That's the PV. So let's mark that up. That's the P. It didn't work very well. It's because I'm not on drawing mode. That is the PV. Let's do the next one. Next piece of information, the percentage rate, 4.5%. 4.5%. So let's go to the interest rate and put in 4.5%. 4.5%. That's the interest rate. So let's mark that up. That's the interest percentage on the GDC. Next one, compounded monthly. I've just realized there that that PV doesn't look much like a PV. So let's just draw that again. That's PV. That's better. Compounded monthly. Let's put that on the GDC. Where does that go? It goes down here. Compounds per year, payments per year. So it's compounded monthly. That's 12 payments per year, 12 compounds per year. Sorry, I should say compounded monthly, compounds per year is 12. So that's the compounds per year, compounds per year. And it's compounded monthly. That's right. Yeah. So that's the payments per year, and compounds per year will be the same. So it's the interest is compounded 12 times per year, and that interest is paid 12 times per year. So there's the same thing. 12. There you go. Not obvious because it says monthly, 12 times a year. She wants this money to last for 20 years. So we go to the calculator, and 20 years. Well, we haven't got a number of years. We've got a number of compounds. We haven't got a number of years. So we have to be a bit clever here and say, well, this is n, and it's 20 times 12. Why times 12? Because of the monthly compound. So there's the link over there. So you've got to link these two pieces of information. That monthly compound is used again to work out the number of payments. There's no such thing as number of years in the calculator. It'd be quite nice, I suppose, if they just had number of years and you put in the number of compounds per year and the number of years, and then they work that out. But it doesn't work that way. It would be probably easier if it did, to be fair. So we put in there 20 years times the number of compounds, 12. 20 multiplied by 12. So that information goes in there, and it does it for you, 240. So there's that. And how much to withdraw each month. Now, the missing information, which is not there, okay, is the future value. So what does the future value? I've got to put that in to find these monthly payments. Well, she wants it to last for 20 years. So to last for 20 years, that would tell you, I think, that the future value would have to be 0 because it lasts for 20 years, means it will be 0 after 20 years. So let's put that in the calculator. The future value will be 0. So we've got number of compounds, that's 20 years times 12, interest rate 4.5, the present value giving in 500,000 into the account, so negative 500,000. The future value is down here, FV, will be 0 because it's going to only last that long, be 0. And the one thing we need to solve for, the last thing, how much can she withdraw each month? And that's PMT. We're solving for PMT, which is payments per term. Payments per term. So that is, so I'll just write solving for PMT. Solving for PMT, payments per term. Okay, so that's how we do these questions. That gives you the present value, percentage rate, compounds and payments per year, N. You've got to do a little bit of work there. You've got to interpret what that means, how long it lasts, means the future value will be 0. Put it on the calculator, there it is. N's 240, I's 4.5, present value negative 500,000, future value 0, payments per year, compounds per year 12, and we're solving for PMT. So the way we do that on our calculator, we hover over that one. Oops, keep doing that. We hover over it like that, and the solve button is here in green, bottom right, SOLVE, solve. How do you get the green button? You press the green option button, alpha. Here we go, alpha, solve, and there we are. There's the answer, $3,163.24 now. One of those odd ones I mentioned last lesson, that you can't take out more money than you've got. So one of those strange math situations where even though the decimal place is following is 6, you'd actually round down. What I mean by that, I will show you now. Answer. There we go. Here's my answer. So let's mark that up. There's my answer there. Whoops. What's my answer? So she can take out, in terms of, it's euros, not dollars, 3,163 euro, 20 something cents. Now you might think, well, the 4 is followed by a 6, a round up, but you can't actually take more money than is in the account. That would take, you'd be taking a tiny little bit extra than you actually have. So I'm pretty sure the financial institution would only give them that much money to the nearest euro cent. You've taken it to the nearest dollar, sorry, to the nearest euro, 3,163. That's how you do them. Part B, find the outstanding balance of a fund after 5 years. What does that mean? Well, it means she's taken these payments out for 5 years. And you might think, well, that's easy, you just work it out and subtract it from 500,000. No, because you've forgotten about the compounding of interest of what she still has left. So now, of course, you have to use the GDC again. You know she's taking this much out PMT every month, because that's what she takes out every month. You just found that out in part A. You know the present value was minus 500,000. That's what she gave into the investment. You know the interest rate is still 4.5. You know the compounds and payments per year is still 12. So what's the only thing that's changed? The only thing that's changed is that it says the outstanding balance after 5 years. And after 5 years, she'd have taken 5 times 12 payments, 60 payments. And we are now solving for the future value, because after those 5 years, it won't be zero because there'll be some money left. You can't do just a subtraction. You can't just multiply that amount of money she takes every month by 60 and then subtract from 500. You can't do that because you've forgotten about the compounding of interest of the investment she's made. So now solve for the future value, and the future value after 5 years of that will be that much. Let's take a snapshot of that. Boom, boom, boom. Shake the room. It's a Fresh Prince reference there for those of you into your 90s. Television repeats on Netflix. There we are. That's it. And that's how you do it. So I'll make some notes there just to make sure you know what I'm doing. Oops, daisy, keep doing that, don't I? Let's do that. It says after 5 years. Yep, 5 years. 5 years, so 5 times 12 hasn't changed. That's the same. 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 And now value of investment after 5 years. Lovely jubbly. There you go. So good luck with those, that asynchronous learning. Make sure you just go through that example with me now with that video. Stop it in places if you need to. Just press the buttons in your calculator, make sure you get the right answers, and then have a go at doing questions 3, 4, and 5. Enjoy your asynchronous learning. Bye-bye.